There is a kind of quiet that lives beyond sound. It isn't silence like the one you find in an empty room or a sleeping forest. It's deeper, older, and softer, like the breath the universe takes between thoughts. Out there, between the stars, the quiet isn't the absence of something. It is the presence of calm itself. Imagine drifting through it, where nothing pulls and nothing presses, where time feels like it has forgotten to move. The stars shine like small candles in a sea without wind. Each one burns patiently, whispering light across endless distances, never rushing, never fading too soon. If you could stand in that stillness, there would be no sound of air, no echo, no beat of wings. Even your own heartbeat would seem shy to break the quiet. You might feel small, but not in a frightening way, more like a leaf resting on a sleeping ocean. The immensity doesn't threaten you. It welcomes you. The universe isn't watching, judging, or measuring you. It's simply existing, vast, peaceful, unbothered. It's an ocean made of stars that hums softly without sound, each one a note in a song too wide to hear. Light travels through this calm like a slow river, flowing for millions of years. It doesn't hurry. It doesn't care how long the journey takes. A beam of light from a star might cross countless galaxies before it touches anything at all, and even then, it lands gently, as if afraid to disturb the dust. Everything here moves, yet nothing seems to move. Planets circle their suns, galaxies drift in their clusters, and entire star systems swirl like glowing petals. But it all feels slow, graceful, and balanced. In this stillness, even motion becomes another kind of rest. If you close your eyes, you might imagine floating there. No ground beneath, no sky above, only the endless velvet of space. It wraps around you like a blanket woven from quiet light. You can feel how weightless existence becomes when there's nothing to resist. The mind, so used to noise, begins to slow. Thoughts stretch out and breathe. You start to realize how much of life is spent chasing sound, chasing movement, chasing meaning. Out here, meaning feels unnecessary. Everything simply is. Sometimes a comet crosses the dark, trailing a faint shimmer behind it. It doesn't shout for attention. It just glides, leaving a soft brushstroke of light. The stars do not compete. Each one glows at its own pace, in its own shade, in its own time. Together they create a harmony made of patience. If peace had a texture, it would feel like this, infinite and gentle. The dark between the stars is not empty. It holds the quiet memory of everything that has ever existed. Invisible clouds of dust drift like forgotten stories. Frozen particles float through light years of calm, carrying the ashes of ancient suns. The atoms that once formed a star might someday become a planet, a tree, or a person breathing under a sky filled with those same stars. In that sense, the stillness between stars is not lifeless, it's waiting. It's the pause before creation. The breath before a thought becomes real. The galaxies, each with billions of suns, look from afar like tiny spirals of dust on a black canvas. They turn so slowly that a full rotation takes longer than the history of human civilization. And yet they move with purpose, guided by invisible threads of gravity. If you could watch them long enough, you'd see the dance. Slow, vast, and beautiful. The universe doesn't rush its steps. It moves like a dream that has all the time it could ever need. Even light, the fastest thing there is, seems unhurried here. It shines because that's what it knows how to do. There's no goal, no race to win. It simply illuminates what exists, and fades softly into the dark beyond. This rhythm of shining, moving, fading repeats everywhere. From the smallest grain of cosmic dust to the largest cluster of galaxies, everything follows this quiet beat. It is the soundless heartbeat of creation itself. If you could listen with your eyes, you might hear it, the rhythm of stillness. Not silence as absence, but silence as fullness. It's what the universe hums when no one is watching. It's the same calm that exists in the space between your thoughts, in the breath you forget to notice, in the pause before dawn. The stillness between stars is not separate from you. It's the same quiet that lives inside you when you stop trying to control the noise. There's something comforting in knowing that out there, far beyond every world we know, peace is the natural state of things. No arguments, no ticking clocks, no urgency, only light and distance, patience and time. The stars have burned for billions of years, and they will burn for billions more. They are not afraid of endings, because every end becomes a beginning. Somewhere a star dies, scattering its ashes into space, and from that dust a new one is born. The universe doesn't mourn, it transforms. Its stillness is not empty. It's generous. Perhaps that's why looking at the night sky feels so healing. It reminds us that calm is not a reward, it's a condition of existence. Beneath the rush of life, beneath every thought and heartbeat, the same quiet exists. When we gaze upward, we aren't just looking at stars. We're remembering something old, something the body recognizes even when the mind forgets. We're remembering the stillness we came from. You can almost feel it now. The peace that hums behind everything. It stretches farther than imagination, wrapping all things in its slow, tender rhythm. From the burning heart of a distant sun to the shadowed edge of an unseen world, the universe is cradled in its own gentle quiet. It doesn't ask for anything. It doesn't promise anything. It simply is. And maybe that's the greatest comfort of all. That in the deepest reaches of space, where no voice can travel and no noise survives, there is this unshakable calm. It reminds us that existence doesn't have to shout to be heard. Sometimes the most powerful thing in the world is the quiet that holds everything together. Between the stars, between the beats of time, there is only stillness. And in that stillness, the universe breathes. The quiet between stars may seem like a great distance, but within it, invisible threads are always at work. They pull softly, shaping the rhythm of everything, from the movement of oceans to the turning of leaves. You may not hear them, but the universe is full of small conversations, spoken in the language of balance. Every motion, every change, seems to listen to something else. It's as if the cosmos hums a melody that everything knows by heart, even if no one ever taught it the tune. Down on Earth, these whispers take form in the way tides move. The moon, silent and pale, leans close to our planet, tugging gently at the seas. Oceans rise and fall, drawn toward her pull as if answering an ancient call. The waves don't question why. They simply obey a rhythm written in light and gravity. If you've ever stood by the shore and watched the tide breathe in and out, you've witnessed one of the simplest, oldest dances, a love story between a planet and its moon. The same quiet communication happens in the wind that moves across a field. Each blade of grass bends not in chaos, but together. The breeze doesn't need to give orders. The meadow already understands. When a gust passes, it ripples across the earth like laughter between friends. You can almost imagine the air carrying secrets from one leaf to another, from one tree to the next. It's a language of motion, patient and without words, reminding us that stillness and movement often share the same soul. Look at a flock of birds turning across the sky. Hundreds move as one, wheeling and folding through the air like a single living shape. No leader calls, no signal flashes, yet somehow they never collide. Their wings speak through the air, each one responding to another's movement. In those swirling patterns, you can see the whisper of a larger harmony. Nature knows something we often forget. That connection doesn't always need to be visible to be real. The same pattern unfolds in the forests. Trees that look like strangers are, beneath the soil, old companions. Their roots touch, share, and send signals through threads of fungi that weave like fine webbing under the earth. A tree in shade can receive food from one in sunlight. An old tree can send warnings about drought or disease to its neighbors. The forest isn't just a crowd of plants. It's a quiet conversation that never ends. Even the seasons speak to each other. Winter's stillness gives way to spring's breath, which grows into summer's warmth before softening into autumn's sigh. The changes come gently, as if the world inhales and exhales in long, patient cycles. The timing is perfect. Flowers bloom when bees wake, rain falls when seeds need it most, and rivers swell just when the land grows thirsty. It's hard not to feel that something unseen is guiding it all, some unspoken understanding written into the bones of time. You can sense these connections everywhere once you start to look. The shape of a snowflake mirrors the pattern of rivers flowing from mountains. The spiral of a shell echoes the whirl of galaxies. Lightning forks across the sky in the same branching form that blood takes through veins and roots take through soil. The same geometry keeps reappearing, as if the universe has a favorite signature and leaves it on everything it creates. At first, it feels mysterious, but maybe it's simply the way life remembers where it came from. Everything that exists is made from the same dust that once floated between stars. When the first atoms joined to form something new, they carried with them a memory of unity. That memory lingers in the tide's pull, in the flight of birds, in the pulse of your own heartbeat. The same patterns echo again and again, like verses of one endless poem. Think about the dawn. When the first light touches the horizon, birds begin to sing, not one at a time, but all at once, as if they know the same cue. The flowers open, the insects stir, and the world begins its day with a synchronized breath. No one commands this. It simply happens. The universe whispers, and everything answers. Even within us, those whispers continue. The rhythm of your heart matches the rhythm of your breath, which follows the rhythm of your thoughts. Your body is a symphony of tiny alignments, cells talking through electric murmurs and chemical messengers. When you feel calm while watching rain fall or waves roll, it's not coincidence, it's recognition. Something deep inside you remembers that you belong to the same quiet order. You are part of the same conversation. Sometimes we forget. The noise of life can drown out the subtle music of connection. But the universe doesn't stop speaking. It keeps sending small reminders. The way sunlight filters through clouds, the way a breeze stirs the trees, the way you feel a sudden calm when you look at the moon. These are whispers meant to be felt, not understood. They don't demand attention. They invite stillness. If you listen closely, you might notice how everything flows into everything else. The rain that falls into rivers becomes the ocean that rises as mist and returns again as rain. The leaf that drops in autumn becomes the soil that feeds spring. The breath you exhale becomes part of the air that a tree will one day give back. The universe keeps reusing itself, turning endings into beginnings, loneliness into belonging. All of it, from the orbit of planets to the trembling of a single leaf, follows a quiet order. Not one of control, but of cooperation. It's a dance that never needs a conductor, because every dancer already knows the steps. This is the whisper the cosmos keeps repeating. Everything moves together, and maybe that's the secret comfort of it all, that we are never truly alone. Even in the silence, even in the spaces between thoughts, the same rhythm beats on. It's the pulse of the universe, gentle and endless, moving through tides and seasons, through the wings of birds and the roots of trees, through every breath you take. You are part of that quiet chorus, humming softly in tune with everything else. The next time you stand beneath the open sky, try to listen. You may not hear words, but you'll feel the connection. The air, the ground, the stars above, all are speaking in the same slow language. It says you belong here. It says everything moves together. It says you are not apart from the universe. You are one of its whispers. Take a moment to notice your own breath, the gentle rise and fall, the steady rhythm that has carried you from your first moment until now. Without thought, without command, it moves, in and out, again and again. This simple motion, so familiar and small, is older than you, older than humanity, older than Earth itself. In that movement, something ancient speaks. It is the same rhythm that guides the stars, the tides, and the turning of worlds. It is the breath of the universe, moving quietly through you. When you inhale, you are drawing in the air that has traveled across oceans and mountains, through forests and storms, through countless other lungs before yours. Each molecule has a story. Some were once part of a leaf's green sigh, some part of a wave breaking under the moon, some part of a flame that burned long ago. The breath you take now might have once belonged to another creature, another century. In this way, breathing is a reunion, a reminder that you are connected to everything that has ever lived. The universe breathes too. Not with lungs or wind, but with the slow expansion and contraction of space itself. Galaxies drift apart, like the opening of a chest, and one day, perhaps, they will draw close again, exhaling back into the quiet from which they came. This grand motion happens on scales far beyond human time, yet its rhythm is not so different from yours. When you breathe in, your body expands. When you breathe out, it softens. The cosmos does the same, across billions of years. You are made of its dust, following its example. Your heartbeat, too, carries that cosmic echo. It beats in time with patterns that shape the universe, cycles of energy, of motion, of renewal. Every pulse pushes life outward, then gathers it back. The sound of a heartbeat is like a small drum playing along with the rhythm of existence. If you listen carefully, you might feel how natural it is, not mechanical, not forced, but as certain as stars that rise and set. The same laws that move planets around suns move the blood through your veins. In a quiet moment, you can feel this unity. The air enters your lungs, fills them, leaves, and returns. Your chest rises and falls, and the world rises and falls with you. The wind outside moves through trees with the same softness. Waves crash, pause, and return. Even the flicker of fire follows a breath-like pattern. Flare, fade, flare again. The universe, it seems, loves this gentle rhythm. It weaves it into every layer of being. It is comforting to think that your breath is not a lonely thing. Each inhale is part of an ongoing exchange that has never stopped since the first light shone. When a forest breathes out, you breathe in. When you exhale, the air begins another journey, perhaps to a mountaintop, perhaps into the lungs of a whale, perhaps into a child yet to be born. The rhythm continues, weaving life together without pause. You are both giver and receiver, participant and witness, never apart from the flow. Sometimes life feels fast, fragmented, or disconnected, but if you slow down enough to notice your breathing, you can feel the thread that ties everything back together. The universe is not distant. It's inside you, moving with each quiet breath. Every heartbeat is an answer to the vastness, a gentle reminder that you belong here, that the cosmos is not something you watch, but something you are. Think about the stars again. Each one burns by drawing in matter, fusing it, releasing energy, inhale, transform, exhale. Even fire follows this same rhythm. Stars die, scatter their elements across space, and from that dust, new stars are born. The breath of creation never stops. The oxygen in your lungs was once forged in such stars, carried across the galaxy until it found its way into you. When you breathe, you are continuing their story. You are the universe remembering itself. This rhythm shows up in other places too, in the beat of waves, the cycle of day and night, the swing of the seasons. The earth breathes in its own way, exhaling warmth in summer, drawing it back in winter. Everything alive follows this same pattern, because everything alive was shaped by the same forces. The pulse of the cosmos became the pulse of life. Even emotions move this way. Joy expands, grief contracts, peace balances between the two. Love itself follows a rhythm, opening to the world, retreating inward, opening again. It's easy to think of these as separate human experiences, but they're part of the same cosmic flow. The universe is breathing through you and feeling as much as in form. If you could see your body not as a boundary but as a bridge, you would realize how continuous everything truly is. Your breath connects you to the sky, your heartbeat to the planet, your atoms to the stars. You are a rhythm within a rhythm, a wave within a larger tide. Nothing about you is isolated. The quiet that began between stars still lives in the space between your breaths. In that awareness, belonging becomes something deeper than comfort. It becomes truth. You don't need to search for connection. You have never been without it. Every breath proves it. Every heartbeat confirms it. The same energy that ignited galaxies flows through your veins, patient and warm. When you pause to breathe, you are not stepping away from life. You are stepping into it. Even death, when it comes, is not the end of the rhythm. It is simply another exhale in a pattern that continues. The atoms that make you will scatter and join the great cycle again. The breath you take now may someday feed a tree, light a star, or fill the lungs of another being who pauses, years from now, to feel the same wonder. The universe doesn't waste its breath. It recycles it endlessly, so breathe. Feel how natural it is. Feel how old it is. Let each breath remind you that you are not apart from the world but woven into it. The same breath moves through oceans, forests, storms, and stars. The same heartbeat that started with the first spark still echoes within you. You are the universe breathing, the cosmos feeling itself for a fleeting moment through your eyes. And in that simple realization, that you are both small and infinite, every story begins with a question. Sometimes it's loud, bold, and demanding. But sometimes, like tonight, it begins softly. A question that doesn't seek an answer right away. It hums in the background, quiet but persistent, waiting for the right moment to be understood. Out among the stars, beneath the calm breath of the universe, that question starts to take shape. It whispers through the stillness, through the rhythm of tides and the flutter of wings, through the pulse of every living thing. Can two things ever truly be one? At first it feels like a simple question, but the longer you sit with it, the more it deepens. You think of the moon and the tide, two separate bodies yet forever connected. You think of the seed and the soil, the sound and the silence that holds it, the breath and the space it fills. Everywhere you look, opposites seem to exist only to meet each other halfway. Day leans into night, life grows from death, sound rises from quiet. The universe, it seems, loves to blur the lines between one thing and another, even you. You are not just one thing. You are both matter and memory, both breath and thought, both stillness and motion. Inside your chest, the heartbeat that belongs only to you is made from atoms that once belonged to stars, to oceans, to ancient winds. Your body is a meeting place of everything that came before. You are one and you are many. Perhaps that is the first clue to the question, can two things ever be one? Or are they already? When you look at the night sky, the stars appear scattered and apart, like islands of light in an ocean of dark. Yet that darkness is not empty. It's what connects them. The space between stars isn't nothingness. It's the fabric that holds them all together. Without that vast darkness, the light would have nowhere to shine. Maybe the stars and the space are not opposites at all, but parts of the same whole. Light needing shadow, sound needing silence, existence needing stillness. Think of a wave. It rises from the ocean, dances across the surface, then sinks back down. We name it, we point to it, we watch it move. But the wave was never truly separate from the water. It was always the ocean, just in motion, wearing a different shape for a moment. When we call it a wave, we forget that it's only the ocean expressing itself. Perhaps everything that looks separate is like that, a temporary shape taken by something larger and shared. Even thoughts move this way. A question forms, rises, lives for a moment, then fades back into quiet, making room for the next. The space between thoughts, that pause, is where they are all born. Maybe that's how the universe works too, as an endless series of questions and pauses, merging and unfolding, two things becoming one, again and again. If you close your eyes, you can feel it, the soft boundary where one thing becomes another. Your breath becomes the air becomes the wind touches the sea becomes the cloud becomes the rain becomes the river becomes the wave becomes the ocean again. It's a circle without a break, each part feeding the next. Separation, it seems, is only a matter of perspective. This idea carries both comfort and mystery. Comfort, because it means we are never alone. We exist as part of something continuous. Mystery, because it means the line between you and everything else is not as clear as it seems. You feel yourself as a single person, but the truth is more fluid. The air that was outside of you a moment ago is now inside your lungs. The warmth that leaves your skin becomes part of the atmosphere. Every breath is a quiet blending, a small proof that two things can indeed become one, at least for a while. Maybe the question isn't about becoming one. Maybe it's about remembering that we already are. Science tells us that at the smallest scale, even particles can't truly be separated. They can become connected in ways that defy distance, entangled as if sharing one invisible thread of reality. When one changes, the other feels it, no matter how far apart they are. The universe doesn't seem to care about the spaces in between. It acts as though everything is part of the same body, and yet we live in a world built from distinctions. Me and you, light and dark, matter and energy, beginning and end. We need these divisions to understand, to describe, to make sense of things. But underneath those lines, something quieter flows. A single, seamless fabric that refuses to be cut apart. The stars, the tides, your heartbeat, your breath, all follow one rhythm, one pulse, one movement that connects every corner of existence. So perhaps the real question isn't, can two things ever be one? But rather, was there ever a time when they weren't? The mind wants to answer quickly. The heart prefers to sit with the wonder. The answer, if it exists at all, might not be found in words, but in awareness, in the feeling of watching the night sky and sensing that you too are part of it. The light that left a star millions of years ago now touches your eyes, and in that instant, two distant things, star and human, meet and share the same moment. For a heartbeat, they are one. This is how every mystery begins, not with noise, but with a whisper. The universe doesn't shout its secrets. It invites you to notice, to wonder, to ask quietly again and again until the question itself becomes a doorway. Can two things ever be one? As you breathe, the question lingers in the stillness, waiting. It doesn't need an answer tonight. It only needs your attention, your curiosity, your willingness to listen. Somewhere in the vastness beyond what eyes can see or science can yet explain, the universe is gently preparing to show you, and perhaps when it does, you'll realize that the question was never about stars or atoms at all. It was about you and everything you touch. The quiet between heartbeats, the space between moments, the meeting point between self and world. The place where two things become one. Imagine zooming in, closer and closer, until galaxies fade, planets shrink, and atoms begin to glow like little stars in the dark. The vast silence of space turns into a humming whisper, a flicker of energy dancing everywhere. Down here, the rules you once knew dissolve. Solidity vanishes. A wall, a table, your own hand, all become clouds of tiny, restless travelers. Each one spins, vibrates, and exchanges invisible messages with the others, as if performing an endless dance choreographed by something unseen. A grain of sand holds more emptiness than substance. Yet within that emptiness, the entire story of existence hides. Electrons orbiting invisible centers, quarks swirling inside protons and neutrons, and something even smaller whispering beneath them, a restless sea of possibility. Scientists once believed that atoms were the end of the journey, the smallest pieces of everything. But curiosity, as it always does, pushed deeper. What they found wasn't a tidy world of building blocks, but a restless realm of motion, uncertainty, and shimmering light. In this tiny world, particles appear and vanish in the blink of an eye. They flicker in and out of being, as if reality itself breathes. Time stretches, space bends, cause and effect blur. It's not chaos. It's a delicate harmony too quick and too small for human eyes to follow. Every bit of matter hums with energy, connected through invisible threads of probability. The closer you look, the more it feels like everything is one continuous field, vibrating, pulsing, aware. You might think this invisible realm is far away, locked inside machines and laboratories. But it's here, within you. The atoms in your skin, the air you breathe, the light touching your eyes, all move by the same quiet rules. Every heartbeat is a ripple in this field. Every thought is an echo of this hidden dance. When you close your eyes and breathe deeply, you are not separate from this microscopic world. You are it. You are made of motion, of waves that never stop singing, of particles that have been everywhere, in stars, oceans, clouds, and other lives before yours. To feel small in this universe is to misunderstand it. You are not standing outside the dance. You are part of its rhythm. The journey ahead will show that these tiny dancers, electrons, photons, quarks, are not lonely. They move in pairs, in patterns, in perfect coordination across unimaginable distances. They whisper secrets to each other faster than light could carry, defying what we think is possible. What happens in one place can echo instantly in another. But before we reach that mystery, pause for a moment. Imagine yourself floating within this invisible realm, surrounded by sparks of possibility. There's no up or down, no distance or direction, only movement and connection. This is not science fiction. This is the real texture of existence. The hidden dance has always been here, unfolding beneath our awareness, binding the vastness above to the stillness within. To step into this world is to glimpse the pulse of creation itself, the heartbeat of the universe, alive in every atom you touch. Down here, in the quiet depths of the quantum world, reason begins to bend. The rules that guide your everyday life, gravity, direction, time, all start to fade like distant echoes. What replaces them isn't chaos, but something deeper, something quietly deliberate. It's a world where either and or are too small to describe what's really happening. Here things can be both until they are one. Imagine holding a coin before it lands. Heads or tails, you know it must be one or the other. But in this realm, the coin isn't just flipping. It exists as both heads and tails at once, a strange blur of possibility. Only when you look does it decide. Until then, it floats between outcomes, as if reality itself is waiting for your attention to take shape. This is superposition. The idea that a single particle can exist in multiple states at the same time. An electron can spin up and down at once. A photon can travel through two paths simultaneously. It's not a trick or illusion. It's the natural rhythm of existence at its smallest scale. The universe doesn't rush to choose. It waits, it balances, it breathes between possibilities, and then there's uncertainty. Not as a flaw, but as a feature. In this world, the more you try to know where something is, the less you can know how fast it's moving. The more clearly you see one truth, the blurrier the other becomes. It's as though nature built a soft boundary around perfection, reminding us that certainty is not the same as understanding. This doesn't mean the universe is random. It means it's alive with potential. Every particle holds 1,000 futures, and which one unfolds depends on how it is touched, seen, or simply noticed. Observation doesn't just reveal reality. It helps create it. You are not a bystander. You are part of the equation. When you think about this, the mind may tighten, trying to grasp it as a puzzle. But the deeper truth isn't meant to be solved. It's meant to be felt. The quantum world moves like a poem, not a machine. It hums with uncertainty because that uncertainty is freedom. Every wave of possibility is an expression of the universe's imagination. Take a breath. Let go of the need for things to make perfect sense. Sense belongs to the middle world. The world of apples falling, clocks ticking, and footsteps echoing on solid ground. Down here beneath logic lies a quieter order. It's not the order of straight lines and perfect rules, but of rhythms, probabilities, and gentle balance. It's the kind of order a dream has. Strange, delicate, yet deeply consistent. If you could watch a single electron, you would never see it sit still. It blurs, it shifts, it disappears and returns, not as a dot, but as a wave spreading across space. It doesn't decide where to be until something asks it to choose. That asking, that simple act of observation, reshapes everything. Physicists call this the collapse of the wave function. But to think of it poetically, it's like the universe whispering, "Now become one." Until that moment, it's all possibility, a graceful hesitation between being and not being. This uncertainty flows through everything, even you. Every atom in your body is built on this same strange balance. Your thoughts arise from quantum whispers, the quiet firing of neurons, the uncertain dance of electrons that make up your brain. Beneath logic, beneath reason, your very being hums with probabilities. It's beautiful when you think about it, that existence doesn't cling to certainty. It allows itself to drift, to explore, to be many things at once. Maybe that's not just how particles live. Maybe that's how we are meant to live too. To embrace uncertainty isn't to lose control. It's to join the rhythm of creation. To accept that not everything must be known, only experienced. Just as the particles move through both paths, we too can walk the narrow bridge between reason and wonder. And so, as we peer deeper into this hidden world, remember, it's not meant to comfort the logical mind, but to awaken something softer, a sense that the universe is more mysterious, more graceful, and more alive than any rulebook can explain. This is the gentle paradox at the heart of everything, that certainty is an illusion. And yet within uncertainty lies the most beautiful order imaginable. Somewhere deep in the hidden realm of particles, a quiet miracle unfolds. Two particles, born together or drawn into each other's influence, begin to share a subtle connection that defies ordinary understanding. No matter how far apart they drift, across meters, kilometers, or even galaxies, they remain linked, a single system moving in perfect coordination. This is entanglement, the universe's quiet conversation, whispering between 2 points, separated by space, yet inseparable in essence. It helps to think of them as dancers in a cosmic ballet. When one moves, the other responds instantly, not because it is told what to do, but because their steps are choreographed as one. The distance between them does not matter. Light years may stretch between their positions, yet in a way invisible to us, they are always aware of each other. Change one, and the other changes too. Not randomly, not chaotically, but with a symmetry so precise it feels deliberate, almost like intention. You might imagine two coins spun at the same time. Normally, each falls independently, but entangled particles behave differently. No matter where you place them, one spin predicts the other. They share a single reality, a single story, expressed in two forms. The universe seems to say, they are one, even when apart. It is as if the particles remember their origin, carrying it with them wherever they go. This connection is invisible, yet it has consequences you can measure. Scientists perform delicate experiments to observe it, but even then, the elegance of the phenomenon is subtle. There is no noise, no flash of light, no dramatic collision. There is only alignment, a gentle echo that spans space. Entanglement doesn't shout. It hums, a quiet agreement between two companions who share the same heartbeat. Imagine two stars born from the same cloud of dust. Even as they drift apart across the cosmos, something fundamental about them remains linked. Their light, their rotation, their elemental composition all speak to a shared origin. Quantum entanglement works on a similar principle, only far more intimate and precise. These particles are not just connected in history, they are connected in being. They are partners in possibility, forever entwined in the dance of existence. The beauty lies in the simplicity of the idea once you let go of expectations. You don't need to picture signals traveling faster than light or forces defying reason. You only need to see it as a quiet unity. Two expressions of the same system, responding naturally to each other. It is as if the universe, in its infinite patience, decided that some things are too delicate to separate. And here's the subtle wonder. Entanglement is not rare. It is a fundamental part of the universe, occurring naturally in countless places. Particles that touch, interact, or emerge together often carry this hidden bond. It is a reminder that separation is often an illusion. What seems distinct may already share a connection deeper than sight or measurement can reveal. Even in your own body, echoes of entanglement resonate. The atoms in your cells once mingled in stars, oceans, and air. They touched. They exchanged energy. They shared space. And those interactions persist in subtle ways, silently shaping the structure of everything you are. The particles that compose you, in their own quantum dance, are never truly isolated. You, too, are a system of endless partnerships. It is tempting to think of entanglement as strange, confusing, or even impossible. But perhaps its strangeness is simply a reminder of how much we have yet to feel, rather than understand. The universe is not constrained by our expectations. Its elegance often lies in simplicity, in connections that don't follow ordinary rules, yet follow a rhythm all their own. Consider this. Even if two entangled particles are pulled to opposite ends of the universe, one will respond to the other in perfect harmony. Distance is irrelevant. What matters is that they are part of a shared whole. Their dance is timeless and immediate, a thread connecting here and there, now and later, one and one again. There is no rush, no struggle, no effort. The connection simply exists, waiting to be observed, waiting to be felt. This idea, that two things can remain one despite distance, despite separation, echoes through everything we have seen in the universe so far. It is the secret behind the tides, the pattern in the leaves, the rhythm of breaths and heartbeats. Some things are meant to move together. to reflect each other, to echo silently across space. Entanglement is a microcosm of this principle, pure and precise. When you imagine it this way, there is no confusion, only wonder. The universe is not broken or inconsistent. It is rich with invisible threads, linking particles, stars, and life in ways both subtle and profound. The hidden dance of entangled partners invites you to see the world not as isolated points, but as a vast tapestry of connection. And so, entanglement becomes more than a scientific curiosity. It is a gentle teaching. The universe allows things to be separate and together at the same time. It shows that unity can exist without merging entirely, that distance cannot undo what has been fundamentally shared. The elegance is quiet, almost meditative. You do not need to rush to understand it. You only need to notice it and let it settle like a soft light in your mind. Perhaps, in the same way, we can learn from this hidden dance. Our relationships, our moments, our thoughts, all can share invisible threads, responding to each other with subtle precision, even across space or time. The world is full of partners in possibility, waiting to be recognized, waiting to remind us that connection is everywhere, in every scale, in every form. And so, as you leave this tiny realm of particles and step back to larger scales, remember this elegance. Two things can indeed be one, not by force or by joining, but by sharing the same rhythm, the same system, the same quiet pulse. Imagine the world as a vast, silent loom. Across its expanse, countless threads stretch, crossing, looping, and intertwining in ways too subtle for the eye to follow. Some threads are thick and obvious, visible in the motions of planets or the sway of trees. Others are fine, delicate, almost imperceptible, yet no less real. Entangled particles move along these hidden threads, linked by invisible connections that stretch across space, binding them together in a quiet intimacy. These threads are not ropes, not wires, not material strands. They have no weight, no texture, no resistance. Yet when one particle moves, the other responds as if tugged by a gentle hand. Distance does not diminish the effect. Even across galaxies, these particles act in unison, following the same invisible pattern. They are partners, partners in possibility, performing a dance choreographed by something far larger than themselves. It helps to think of two notes in a song, sung in harmony even when far apart. The first note rings, and the second seems to respond instantly, echoing its shape and tone. You could separate them by walls, by oceans, by time itself, and still the harmony persists. The threads are silent, yet the music travels along them effortlessly, weaving together what appears separate into a single coherent whole. There is a quiet poetry in this. The universe, in all its vastness, often appears disconnected, with stars scattered across emptiness, planets isolated in darkness, and lives unfolding in solitude. But these invisible strings suggest otherwise. There is always a link, always a resonance. Some of it we can measure, some we can only feel. Even without understanding fully, we can sense the elegance of the connection. Imagine the strings stretching from one particle to another as a soft filament of light, shimmering faintly in the space between. When one moves, the filament vibrates, and the other particle moves in response. It is not a signal sent through ordinary space. It is a shared existence, an invisible bond that transcends distance. The particles are not communicating in the way we speak. They are sharing the same reality, two expressions of one whole, endlessly reflecting each other's state. You can see the metaphor everywhere in life. Think of the moment when a friend knows what you are feeling before you say a word. Think of the way two people in deep connection can mirror each other's movements or emotions. The universe itself practices this quiet empathy through particles linked by threads we cannot see but whose effects are unmistakable. The invisible strings remind us that separation is never absolute. Even on a personal scale, consider your breath. The air entering your lungs today may once have passed through forests, oceans, or other humans long ago. It is part of a shared flow of matter and energy, a thread connecting you to the planet and the past. Entangled particles are the same principle written at the smallest scales. Nothing is ever truly alone. Every movement is part of a larger tapestry, every vibration part of a cosmic rhythm. These threads are also timeless. They were formed in the birth of the particles, often before time as we know it began. Once established, they endure. Separation does not sever them. Distance does not weaken them. You could place two particles at opposite ends of the universe, and they would continue their dance, connected by the invisible string that has always existed. In this way, entanglement becomes a quiet meditation on unity, permanence, and the delicate balance that underlies all of existence. To imagine the threads visually is to sense something almost magical. They float unseen, moving like currents of water through space, responding to the particles' states with a perfect, effortless precision. There is no tension, no struggle, only coordination. They are the silent scaffolding of reality, holding together pieces that might otherwise appear unrelated. And when you begin to feel them in your mind, the world itself seems softer, more connected, more alive. Perhaps the most profound lesson of the invisible strings is that connection can exist without closeness. The particles need not touch. They need not meet. And yet, the universe ensures they remain bound. In the same way, some relationships in life, between people, moments, or even ideas, resonate across space and time. They are invisible, intangible, yet their effects are undeniable. Entanglement shows us that unity can exist without obvious proximity, that the quiet bonds of reality are often hidden, waiting for perception to notice. Even your own existence resonates with these threads. The atoms in your body were once elsewhere, in the oceans, in stars, in the soil of ancient lands. They met, they mingled, they moved apart. Yet they remained connected through the ongoing flow of matter and energy. You are a living network of invisible strings, a small echo of the larger entangled cosmos. Every heartbeat, every breath, every thought is a subtle vibration on threads that stretch far beyond yourself. And so, in the serenity of this hidden world, it is possible to feel both wonder and calm. These invisible strings do not scream for attention. They do not demand recognition. They simply exist, elegantly, gracefully, quietly sustaining the harmony of the universe. They are a reminder that beneath what seems chaotic or disconnected, a delicate, invisible order persists. When you close your eyes and imagine it, the picture becomes clear, a universe not of isolated dots, but of luminous threads vibrating silently, linking stars, particles, and lives. Entanglement is the gentle proof that connection is woven into reality at every level, from the tiniest electron to the vastest galaxy. The invisible strings are not just a scientific curiosity. They are a meditation on unity, an invitation to see the universe not as separate pieces, but as a web of delicate, eternal relationships. And in that imagination, there is serenity. There is a quiet smile in the knowledge that nothing truly drifts alone, that every particle, every being, every heartbeat participates in the hidden dance. The strings are invisible, but their presence is everywhere, a reminder that connection is the natural state of all things. To notice them is to step into the universe's most intimate secret, and to feel ever so gently that we are never apart. Albert Einstein was, by most accounts, a man of astonishing clarity. His hair, a wild halo around his thoughtful face, became almost as famous as his ideas. But beneath the recognizable exterior, behind the confident stride and the quiet humor, there lived a mind wrestling with a paradox that would challenge the very foundations of physics. While the world celebrated the strange, beautiful consequences of quantum theory, Einstein remained uneasy, a guardian of order in the face of uncertainty. He had always sought simplicity in nature. The laws he imagined were elegant, flowing from principles so clear they could illuminate the universe like sunlight spilling over a mountain. Gravity, relativity, the curvature of space-time. These were not mysteries to him. They were poems of logic, where every element had its place, every action its cause. And yet, as quantum mechanics began to rise, with its superpositions and probabilities, its entangled particles whispering across impossible distances, he found himself unsettled. Einstein did not reject the mathematics or the experimental evidence. He respected them meticulously, rigorously, but he could not accept what the results implied. Particles could be in two states at once. Measurement could shape reality. Objects could instantaneously influence one another across space. It was as though nature, in its tiniest expressions, had started to flirt with paradox, and Einstein could not join the dance. He described his discomfort with words that carried both humor and exasperation. God does not play dice with the universe. It was not a theological claim, though many misunderstood it that way. It was a declaration of principle, a refusal to accept randomness as the ultimate foundation of reality. The universe, he believed, was orderly, coherent, and intelligible. Chance could exist, but it could not rule. Einstein's skepticism was also profoundly human. He was not a rebel for the sake of rebellion. He was a seeker. And the quantum world's suggestions of immediacy, uncertainty, and hidden connections seemed to mock the clarity he so cherished. How could he reconcile the apparent chaos at the micro scale with the smooth elegance of the cosmos he had come to know? He felt a tension, a quiet unease, a challenge he could not ignore. He engaged with colleagues thoughtfully, sometimes playfully, sometimes sharply. In debates with Niels Bohr, the leading champion of quantum theory, Einstein pushed for clarity, for hidden variables, for explanations that would restore the predictability he craved. Bohr, patient and philosophical, countered with arguments grounded in experiment and mathematical beauty. Their conversations were polite but profound, full of laughter, pauses, and the tension of two minds exploring the edge of understanding. One of Einstein's famous thought experiments illustrated his concern. Imagine two particles, he suggested, separated by great distance. If one is measured, the other responds instantly. If reality truly worked this way, he argued, it would suggest a spooky action at a distance, a phenomenon he could not accept without explanation. To him, the idea of instant influence across space violated the very principle of causality, the fabric of reason itself, and yet Einstein did not close his mind entirely. He observed, he calculated, he questioned. His letters reveal a man deeply respectful of the universe's mystery, even when it unsettled him. He admitted privately that perhaps nature had tricks to play that human minds could not fully grasp. But he insisted that any ultimate theory must be coherent, must provide a complete picture, must explain why particles behaved as they did without abandoning the certainty that reason demanded. To understand Einstein is to recognize the tension of genius confronted with the unknown. He had illuminated vast truths, yet here he stood before a world that resisted simple description. It was not stubbornness, it was devotion. Devotion to the idea that understanding should ultimately be complete, elegant, and satisfying. The universe, he believed, must have a story that made sense, even if that story lay hidden from view. This conflict humanizes him. It is easy to imagine a mind so brilliant that nothing could unsettle it. But Einstein's brilliance was matched by his honesty, his willingness to admit confusion, his capacity to wrestle with doubt. In this wrestling, he reveals something universal, the tension between what we expect and what the world presents, between the order we hope to see and the strangeness that insists on existing, even in moments of solitude. Walking along a quiet street or sitting in his study, Einstein carried the questions with him. The universe, in its smallest details, was teasing him with its subtle, hidden dance. Particles behaving as if they were one across distance. Uncertainty shaping outcomes. The randomness of probability. He felt both awe and frustration, fascination and reluctance. Yet there was also beauty in this struggle. Einstein's skepticism did not blind him to wonder. It sharpened it. His questions pushed the field forward, encouraging others to look deeper, to test harder, to challenge their assumptions. Without his probing mind, the foundations of quantum theory might have seemed less real, less examined. His reluctance became, paradoxically, a source of illumination, guiding physics toward clarity through the tension of doubt. In the end, Einstein's skepticism was a testament to his humanity. It reminds us that even the greatest minds experience tension, confusion, and discomfort in the face of mystery. It shows that curiosity does not always mean immediate acceptance, that wonder can coexist with questioning, that respect for nature requires both openness and critical thought. He modeled the delicate balance between faith in reason and awe at the unknown. As we reflect on his stance, we see a man standing at the edge of the invisible threads, watching them sway, trying to understand their motion without stepping into them. His discomfort, his questions, and his brilliance together form a portrait of a thinker profoundly engaged with the universe. He struggled not because he was limited, but because he sought perfection in understanding, a clarity that could encompass the strange, entangled and hidden world beneath logic. And so, in considering Einstein, we encounter a universal truth, that confronting mystery is as much about the mind as it is about the heart, and that genius often takes the form of relentless questioning, coupled with a deep, enduring respect for the beauty of what is yet unexplained. In this, Einstein was not just a scientist, but Einstein had a way with words, especially when he wanted to capture both astonishment and disapproval. In the early decades of the 20th century, as quantum mechanics rose from the minds of brilliant physicists, he observed something so strange it made him shake his head and chuckle at the absurdity. Particles, it seemed, could influence one another instantly across impossible distances. He called it, with a mixture of fascination and exasperation, spooky action at a distance. The phrase stuck, not just because it was colorful, but because it perfectly conveyed the sensation of the phenomenon. Imagine watching a magician pull a coin from behind someone's ear, then realizing the coin was never there to begin with. Now imagine that trick happening between two particles, separated by miles, where one particle instantly responds to the other's movement, as if they shared some secret connection invisible to the world. That is what Einstein saw, and he could not help but call it spooky. The humor in the term does not hide the seriousness of his concern. For Einstein, physics was supposed to describe reality in clear, understandable ways. Causes should lead to effects. Distances should matter. If one particle changed, how could another, light years away, react immediately? It seemed like the universe was ignoring its own rules, playing a practical joke at the expense of logic. And yet experiment after experiment confirmed it. The world, it appeared, had a sense of humor of its own. To imagine this, picture two entangled particles as dancers in separate rooms. One leaps, and the other responds without seeing the first move, without hearing a sound, without any obvious signal. The choreography is perfect. The timing is exact. There is no communication as we understand it, yet they mirror each other flawlessly. Einstein's reaction was part amazement, part disbelief, part wry amusement. Even the universe, he seemed to think, could be mischievous. The term spooky action at a distance also hints at Einstein's discomfort with mystery. He preferred the universe to be a book written in plain, legible script. Here was a phenomenon that refused to be read easily, a hidden script written in invisible ink. He wanted answers, explanations, not a cosmic practical joke. But he could not dismiss the evidence. It was real. It worked. It existed whether he liked it or not. And so he laughed, sighed, and coined a phrase that captured the strange mix of wonder and frustration. Yet Einstein's humor was never cruel or dismissive. It was thoughtful, playful, a way of engaging with the universe on human terms. The spooky particles were, in a sense, companions in his intellectual journey, teasing him with their unpredictable behavior, nudging him to think differently, and reminding him that even a genius could encounter the delightful absurdity of nature. This spookiness is not random. Entangled particles do not flail about in chaos. They follow precise rules, obeying the hidden order of their shared system. The word spooky is playful, yes, but also respectful. It acknowledges that nature has depths we do not yet fully understand, and that even the brightest minds must marvel at its subtleties. Einstein recognized the phenomenon's seriousness, but he also recognized its whimsy, the quiet joke written into the fabric of reality. Entanglement forces us to reconsider distance. In our everyday experience, space separates, divides, isolates. Yet in the quantum realm, distance becomes irrelevant. Two particles, even if placed at opposite ends of the universe, remain instantly aware of each other. It is as though the cosmos contains invisible threads, tiny lines of understanding that defy our ordinary sense of measurement. Einstein's phrase captures that tension perfectly, the eerie, almost comic defiance of expectation, where science meets mystery and raises an eyebrow at reason. There is also a deeper lesson in the humor. By calling it spooky, Einstein humanized a concept that could have remained intimidating and cold. He invited others to approach quantum strangeness with curiosity rather than fear. He acknowledged that reality could be baffling, yet still wondrous, a puzzle to explore rather than a problem to dread. Even in his skepticism, there was an invitation to wonder. Consider for a moment how this might feel to an ordinary observer. A person standing quietly in a lab or imagining the phenomenon from home. You picture two entangled photons light years apart. One shifts, the other responds instantly. You smile at the impossibility, and perhaps like Einstein, you mutter to yourself, "How delightfully spooky." There is charm in the absurdity, a quiet amusement that coexists with profound respect. The experiments that confirmed entanglement took decades to refine. Yet every step reinforced the truth of Einstein's observation. The spooky action was real and it was measurable. Scientists could predict outcomes, manipulate particles, and even apply these principles in technology such as quantum computing and cryptography. The humor remained, though, because what was so logical and calculable in practice seemed so fantastical in imagination. In this way, Einstein's phrase endures. It captures a moment of human reflection in the face of the unimaginable. It reminds us that even the most precise minds encounter moments where nature plays tricks, where rules bend, and where we are left laughing softly, a little dazed, and completely fascinated. Spookiness becomes a bridge between rigorous science and human experience. A gentle acknowledgement that the universe is not only vast and complex, but occasionally mischievous. Ultimately, the particles continue their invisible dance, linked by entanglement, responding to one another with perfect precision and leaving us to marvel. And we, like Einstein, can approach them with calm amusement. We can smile at the universe's quiet whimsy while appreciating the profound truths hidden beneath. The cosmos is playful, elegant, and surprisingly charming. Sometimes it whispers secrets through invisible threads, and sometimes it simply raises an eyebrow, saying, "Did you expect it to be any other way?" Einstein's spookiness is a reminder that science is a story told not only in equations and experiments, but also in wonder, in humor, in human curiosity. It is a story in which the universe invites us to lean closer, to observe, and occasionally to laugh softly at the delicate absurdities that nature offers. The entangled particles keep dancing, the threads keep vibrating, and somewhere in the mind of a curious observer there is a quiet smile acknowledging the uncanny, delightful spookiness of it all. In 1935, Albert Einstein, Boris Podolsky, and Nathan Rosen published a paper that would become one of the most famous debates in the history of physics. Today, it is referred to simply as the EPR paper, named after their initials. Its purpose was not to disprove quantum mechanics outright, but to ask a critical question. Could the theory be complete if it allowed such strange, instantaneous connections between particles? Einstein believed that any adequate description of reality should be clear, complete, and grounded in locality. The idea that objects are influenced directly only by their immediate surroundings. To understand their argument, imagine two particles created together and then separated by a great distance. According to quantum mechanics, these particles can become entangled, meaning their properties are linked even when far apart. If you measure one particle's property, say its position or momentum, the other particle's corresponding property is instantly known, regardless of distance. To Einstein, this instantaneous connection seemed to violate a fundamental principle: nothing should travel faster than light. Einstein, Podolsky, and Rosen reasoned step by step. First, if you can predict the result of a measurement on one particle by observing its distant partner, then the property you are predicting must have been determined already. It could not suddenly be created by the act of measurement. In other words, reality exists independently of observation. They called this elements of reality. If quantum mechanics cannot assign definite values to these elements without measuring them, then the theory is incomplete. The logic is deceptively simple. If reality exists independently, and if measuring one particle reveals a property of its distant partner without any delay, then either information is somehow traveling faster than light, which seemed impossible, or quantum mechanics does not provide a complete description of reality. Einstein preferred the latter explanation. He wanted a deeper underlying theory that could account for the correlations without requiring spooky action at a distance. To illustrate, picture a pair of gloves. One is left-handed, the other right-handed. You place them in two separate boxes and send one box to New York and the other to Paris. When you open the box in New York and see the left-handed glove, you immediately know the glove in Paris is right-handed. No mystery, no magic, no faster-than-light influence. The gloves had definite properties all along. Einstein imagined that particles might be like these gloves. They have predetermined characteristics. But quantum mechanics, as it stood, could only describe probabilities. However, quantum theory introduced a complication. Unlike gloves, particles can exist in a state of superposition, multiple possibilities at once, until they are measured. A particle does not have a definite position or momentum. It is both, or neither, or somewhere in between in a mathematical wave of probabilities. Measurement forces the particle to choose a state. For entangled particles, this choice seems to happen instantaneously for both, no matter how far apart they are. Einstein found this deeply unsettling. The EPR paper argued that if quantum mechanics cannot describe the properties of particles fully, then the theory must be incomplete. There must be hidden variables, unknown factors that determine outcomes, that restore determinism and locality. These hidden variables would explain why particles appear entangled without requiring instantaneous communication. In essence, Einstein asked, can a theory be considered complete if it cannot predict reality precisely without outside intervention? The paper carefully avoided attacking quantum mechanics as a whole. Instead, it posed a challenge. If quantum theory was correct, then nature must behave in ways that seemed illogical, violating the speed of light or common sense. If nature did not behave that way, then the theory was incomplete, missing some deeper layer of reality. The EPR paradox thus became both a philosophical question and a scientific challenge, a way of pressing physicists to examine the assumptions underlying quantum mechanics. Einstein's argument was steady, logical, and deeply human. He was not content with results that defied intuition. He wanted a coherent narrative of the universe, one in which cause and effect, space and time, and reality itself made sense. The EPR paradox was an invitation to think carefully, to question assumptions, and to seek a theory that was both mathematically precise and physically meaningful. Despite its clarity, the paper sparked decades of debate. Niels Bohr and other proponents of quantum mechanics responded by defending the completeness of the theory, arguing that nature simply does not conform to classical expectations. They suggested that the paradox arises only if one assumes that particles have definite properties independent of measurement. Quantum mechanics, they argued, is a different kind of theory, one that is probabilistic and contextual rather than deterministic. The dialogue that began with the EPR paper became a cornerstone of modern physics. It inspired experiments that tested entanglement with increasing precision, eventually confirming that entangled particles do act in the spooky way Einstein had observed, even across large distances. Yet the paradox remains a touchstone for thinking about the nature of reality, the limits of knowledge, and the tension between intuition and observation. In essence, the EPR paradox shows us Einstein at his most thoughtful and principled. He is not rejecting evidence, nor is he clinging stubbornly to outdated ideas. He is asking a profound question. Can a theory describe the world completely if it leaves out hidden truths, if it allows outcomes that seem disconnected from any underlying cause? The question is simple, the implications vast. It is a quiet insistence on clarity in a universe that sometimes refuses to be simple. Even today, the EPR paradox serves as a bridge between the human desire for understanding and the universe's willingness to surprise. It is a reminder that science is not only about discovering facts, but also about grappling with ideas, weighing evidence, and questioning the coherence of our models. Einstein's logic, calm and steady, invites us to explore reality thoughtfully, to value both curiosity and rigor, and to recognize that some puzzles are as much about our thinking as about nature itself. In the end, the EPR paradox does more than critique quantum mechanics. It celebrates it. By framing the problem clearly, Einstein provided a lens through which generations of physicists could explore the hidden connections of the universe. It is a testament to his brilliance, his patience, and his enduring commitment to understanding reality, not just as mathematics, but as a story that makes sense in its own quiet, intricate way. The moment Einstein, Podolsky, and Rosen presented their paradox, the world of physics stirred quietly but decisively. Here was a question that invited reflection, debate, and curiosity. It was not shouted across lecture halls, nor emblazoned on newspaper headlines. Instead, it traveled carefully through journals, letters, and conferences, settling in the minds of those willing to think deeply. Scientists read the EPR paper not as an accusation, but as a challenge, a polite, persistent prod to examine the foundations of the emerging quantum world. At first, reactions varied. Some dismissed it as a philosophical diversion, a clever argument that did not alter calculations or predictions. To them, quantum mechanics worked beautifully. The equations produced accurate results, and the technology of the time, cathode ray tubes, spectroscopy, atomic models, depended on it. Why question what functioned so well? Yet others were intrigued. Here was a paradox that teased the intellect, suggesting that beneath the reliable patterns of measurement, there lay a deeper structure of reality, hidden from immediate view. The debates were polite, often intensely cerebral, Niels Bohr, for instance, engaged Einstein directly, defending the probabilistic interpretation of quantum mechanics. He argued that reality at the quantum level need not resemble our everyday experience. Particles need not have pre-existing properties independent of measurement. Where Einstein sought clarity and determinism, Bohr offered context and complementarity. The idea that properties reveal themselves only when observed within a specific framework. Their exchanges, sometimes fiery, sometimes gentle, became legendary, the epitome of intellectual engagement with both respect and rigor. Others joined the conversation, including Wolfgang Pauli, Erwin Schrödinger, and John von Neumann. Each brought unique perspectives, mathematics, and philosophy to the debate. Schrödinger, for example, coined the term entanglement, Verschrankung in German, to describe the phenomenon Einstein found so troubling. He also created thought experiments, like the famous cat in a box, to illustrate how superposition and measurement challenge classical intuition. These ideas spread through seminars, letters, and informal discussions, seeding a growing awareness that quantum theory was more than just abstract mathematics. It posed profound questions about the nature of reality itself. Despite the intellectual excitement, many physicists approached the EPR paradox cautiously. Experiments capable of testing entanglement were not yet possible. The technology of the 1930s and 1940s did not allow precise measurement of particle correlations over distance. For a time, the debate was philosophical, a dialogue among theorists. But that did not diminish its significance. The paradox illuminated gaps in understanding, raised questions about locality and completeness, and suggested possibilities that extended beyond the laboratory. As the decades passed, experimental physics began to catch up. Advances in lasers, detectors, and photon control allowed researchers to test entanglement in ways Einstein could only imagine. Experiments became increasingly precise, measuring correlations between particles separated by meters, kilometers, and eventually tens of kilometers. Each success confirmed the predictions of quantum mechanics, showing that entangled particles responded to one another in ways that seemed to defy classical logic. The physics community took notice not as alarm, but with measured excitement. The once purely theoretical discussions became tangible observations. The transition from theory to experiment changed the conversation subtly but profoundly. Philosophical musings evolved into rigorous data collection. Labs designed experiments to isolate, measure, and confirm entanglement. The debate shifted from, could it be possible? To, how exactly does it manifest and how can we use it? Quantum mechanics, once abstract and sometimes intimidating, began to reveal itself as not only accurate, but also experimentally verifiable in its most puzzling aspects. The community was, in a quiet sense, learning to embrace what Einstein had called spooky action at a distance. Yet even as experimental confirmation arrived, the dialogue remained thoughtful. No one claimed absolute understanding. Scientists recognized that entanglement challenged intuition, forcing them to expand their conception of space, time, and causality. Journals published careful analyses. Conferences featured rigorous debates. Graduate students and young researchers were captivated not just by the mathematics, but by the philosophical implications. A universe where distance mattered less than connection, where observation influenced reality, and where certainty was never absolute. The growing experimental evidence also inspired new ideas and technologies. Physicists realized that entanglement could be harnessed for communication, encryption, and computation. The quantum world, once a realm of paradox and speculation, became a laboratory of possibility. Each successful experiment reinforced the principle that theory and observation, when aligned, reveal something both astonishing and deeply reliable. The community's initial caution evolved into a collective fascination, an acknowledgement that nature, though sometimes bewildering, could be understood through careful inquiry. Throughout this period, Einstein's influence remained present, even if indirectly. His insistence on questioning completeness and locality pushed physicists to design the experiments that would one day confirm entanglement. By challenging assumptions, he had inadvertently laid the foundation for a deeper exploration of reality. His skepticism, balanced by respect for evidence, became a model for intellectual rigor. The community's attention was as much a tribute to his probing mind as to the mysterious particles themselves. In this way, the world of physics shifted subtly, like a pendulum moving from theory to experiment. The quiet corridors of thought, where paradoxes were debated, gave way to laboratories where photons, electrons, and atoms were observed with unprecedented precision. The abstract became concrete. Ideas once confined to chalkboards and papers now had measurable consequences. The EPR paradox had accomplished its goal. It forced the world to notice, to measure, to confront the reality that entanglement is not a mathematical curiosity, but a fundamental feature of the universe. By the mid-20th century, entanglement was no longer merely a philosophical question. It had become a subject of careful observation, of reproducible results, and of gentle awe. The physics community, once skeptical or amused, now treated it as an essential aspect of reality. Yet even with experiments confirming the phenomena, the questions Einstein raised remained alive. How does nature manage these connections? What does it mean for our understanding of space, time, and causality? The dialogue, begun with a paper in 1935, had matured into a quiet but profound exploration of the invisible threads that connect everything. And so, the world took notice, not with fanfare or sensationalism, but with deliberate, patient attention. The theory and experiment joined hands, revealing a universe that is subtle, intricate, and astonishingly interconnected. The transition from abstract argument to measurable reality was complete, yet the sense of wonder endured. Scientists looked at entangled particles and saw both mystery and method. By the 1960s, the debate over quantum entanglement had settled into two parallel paths: philosophical discussion and experimental possibility. Einstein had raised the paradox, Bohr had defended the quantum view, and decades of thought experiments had illuminated the strange implications of particles connected across space. Yet the question remained, could this subtle, invisible connection be measured? Could entanglement move from abstract theory into observable reality? John Bell, a physicist from Northern Ireland, stepped quietly into this stage with a question that would change everything. Bell approached the problem with a simplicity that belied its power. He asked, if particles have hidden variables that determine their behavior, the kind Einstein had hoped existed, then there should be limits to how strongly the results of measurements on two entangled particles can correlate. He formulated an inequality, now known as Bell's inequality, which described exactly what would be expected if nature followed classical logic and hidden variables. If measurements violated the inequality, it would mean the hidden variable explanation was insufficient, and that entanglement truly defied classical expectations. The beauty of Bell's theorem lies in its accessibility. Imagine two coins, linked in some invisible way. If each coin had predetermined sides, their outcomes would be limited by simple probability. You could calculate how often they should match or differ. But if the coins could somehow influence each other instantly, without predetermined sides, their correlations could exceed the classical limit. Bell's inequality quantified this difference, providing a measurable test between two competing realities, one governed by local determinism, the other by entanglement's spooky connection. Bell's insight transformed entanglement from a conceptual curiosity into an experimental challenge. For decades, physicists had speculated, calculated, and debated, but no test could conclusively demonstrate whether the hidden variable hypothesis held true. Bell's theorem offered a bridge between the abstract and the tangible. It said quietly and precisely that reality could be probed. That measurement could reveal whether particles were independently predetermined or genuinely entangled. The theorem itself is mathematically elegant, but the underlying idea can be explained without equations. Imagine two particles, born together and separated by distance. Each particle can be measured in one of several ways, and each measurement can yield different outcomes. If the particles are governed by hidden variables, the patterns of their results must obey a certain constraint. If the particles are truly entangled, the correlations will exceed that constraint, producing results that cannot be explained by local properties alone. Bell quantified exactly what that constraint should be. When the physics community received Bell's paper in 1964, reactions were subtle but profound. Many recognized the importance immediately, though the implications were slow to sink in. Experiments capable of testing the theorem would require careful design, precise equipment, and patience. The technology of the 1960s was advancing, but the idea that quantum entanglement could be tested over measurable distances was still revolutionary. Yet Bell's contribution had shifted the debate. No longer was entanglement a matter of philosophy. It had become an empirical question. To imagine the experiment, picture a pair of photons traveling in opposite directions, each entering a detector capable of measuring polarization, the orientation of the wave's oscillation. The detectors can be set to different angles, and the results are recorded. By comparing many such measurements, scientists can calculate correlations. If the correlations exceed Bell's limit, the results demonstrate that the photons are entangled in a way that cannot be explained by hidden variables. It is a simple, elegant test. Measure, compare, and see which version of reality prevails. The first experimental attempts were modest but illuminating. Physicists such as John Clauser, Stuart Friedman, and later Alain Aspect in France designed increasingly sophisticated setups to test Bell's inequality. They measured thousands, then millions of photon pairs, checking carefully for any source of error or interference. Each iteration refined the experiment, reducing loopholes and increasing confidence. The results, time and again, violated Bell's inequality, confirming that entangled particles behaved in ways that defied classical assumptions. Bell's theorem also revealed something deeper. The universe operates according to rules that are profoundly interconnected, even at a distance. Measurement is not merely passive observation, it is an active engagement with reality. Two entangled particles are not independent. They share a subtle unity that persists across space. The correlations are precise, predictable, and consistent, yet they cannot be explained by local properties alone. Entanglement is real, measurable, and astonishingly robust. Beyond the experimental confirmation, Bell's insight changed the way physicists thought about nature. It forced a reconsideration of causality, locality, and determinism. The results suggested that the universe is not merely a collection of independent objects obeying local rules. It is a web of relationships, a network of correlations, subtle and precise. For the first time, a conceptual puzzle proposed by Einstein decades earlier became a tool for discovering the structure of reality itself. The calm clarity of Bell's approach, formulating an inequality, imagining a feasible experiment, and defining measurable predictions, embodies the elegance of good science. He did not need to explain every mystery. He needed only to create a lens through which the truth could be observed. And through that lens, the universe revealed itself, confirming the entangled connections Einstein had once found so troubling, and giving experimental weight to the invisible threads that bind particles together. In this way, the Bell test bridges theory and reality. It transforms abstract mathematics into concrete observation, philosophical paradox into measurable phenomenon. The implications are far-reaching, influencing quantum computing, secure communication, and the ongoing exploration of reality at its most fundamental level. Yet the heart of the achievement remains simple and human: a clear question, a careful test, and the quiet satisfaction of knowing that some of nature's most hidden behaviors can be observed and understood. Bell's theorem reminds us that the universe is at once strange and intelligible, playful and precise. It reassures us that even in the smallest scales clarity can emerge, and that curiosity guided by rigorous thought can reveal truths beyond imagination. The photons dance, the measurements are recorded, the correlations exceed the limit, and we see, with calm certainty, the invisible threads at work, immeasurable, astonishing proof that reality is more interconnected than we ever dreamed. The laboratory was quiet, almost reverent, as Alain Aspect and his team prepared for the night's experiment. It was 1982 in a French laboratory tucked between streets and the hum of city life, yet inside, time seemed to slow. Rows of equipment stood like sentinels, wires snaking across tables, lasers poised to emit beams of light with exacting precision. Everything had to be perfect. Even the slightest vibration could ruin the delicate dance of photons. Aspect moved carefully, checking instruments and noting readings. The air was filled with the low, constant hum of machinery, pumps, detectors, and power supplies, a soft symphony of technology anticipating discovery. Each photon about to be emitted was invisible, almost ghost-like, yet each carried the potential to reveal a profound truth about the universe. The team exchanged quiet glances, the weight of expectation palpable but never shouted. There was a shared understanding. Tonight, they would test the reality of entanglement itself. The experiment was elegant in its design. Pairs of photons would be generated, each traveling in opposite directions. Their polarizations would be measured at detectors set meters apart, with settings chosen rapidly and independently. The goal was to see if the photon's outcomes correlated in a way that violated Bell's inequality. If they did, the results would confirm that entanglement is not merely theoretical, but real, observable, and inescapably strange. The night carried a quiet tension, the calm before revelation. As the first photon pairs were emitted, the room seemed to hold its breath. Each particle, invisible and untouchable, embarked on its journey through the lab's intricate apparatus. Detectors clicked softly as photons were measured, and the data began to flow onto screens. Numbers appeared, tiny flickers of evidence that would either uphold classical expectations or defy them. Aspect and his team watched silently, a hush of anticipation hanging over every movement. It was a night not of explosions or spectacle, but of subtle, precise observation, where significance arose in patterns and correlations rather than in grand gestures. Minutes stretched into hours. The team monitored the experiment, adjusting parameters, ensuring alignment, double-checking timings. Outside, the night deepened, but inside, the lab was alive with focused energy. Each photon was a messenger, carrying the potential to reveal the hidden threads Einstein had once called spooky action at a distance. Aspect could feel the weight of history pressing softly against the walls. Decades of debate, questions and thought experiments culminating in this precise moment of observation. As the data accumulated, the correlations became clear. The photons behaved exactly as quantum mechanics predicted. The measurements violated Bell's inequality, confirming that the outcomes could not be explained by local hidden variables. It was as if the universe in its quiet elegance had whispered a secret to the team. The room remained still, the revelation not shouted but acknowledged in the soft exchange of looks, subtle nods, and the gentle tapping of keys to record the results. There was a sense of immersive awe in the lab that night. These were not abstract numbers. They were evidence of an invisible connection, a shared reality between particles separated by distance. Aspect and his team felt it almost physically, a quiet shiver of discovery that does not demand excitement, but commands reflection. The photons had traveled their paths faithfully, revealing the hidden dance of entanglement, the mysterious coherence that links the quantum world across space. Cinematic in its subtlety, the night unfolded like a carefully directed scene. Shadows cast by the equipment flickered across the walls. Screens glowed with data, illuminating the scientists' faces in pale light. Each click of a detector was a heartbeat, a pulse in the rhythm of measurement. Outside, the world slept, unaware that a small room in France had captured the delicate choreography of the cosmos, one photon at a time. Aspect allowed himself a moment of quiet satisfaction. The experiment validated years of theory, but more importantly, it bridged imagination and reality. Entanglement, once a paradox, was now observable. The universe, playful and precise, had spoken through photons, confirming the invisible threads Einstein had speculated about, the connections that defy distance, the subtle coherence that makes quantum mechanics not just strange, but beautifully real. The night did not end with fanfare. There were no fireworks or applause. The team, exhausted yet elated, recorded the final results, checked the consistency, and prepared for repeat trials. Each run reinforced the discovery, the quiet suspense giving way to calm certainty. It was a triumph of patience, precision, and persistent curiosity, a reminder that profound insight often arrives not in spectacle, but in careful observation and measured reflection. By the time dawn approached, the lab was alive with gentle excitement, tempered by the soft discipline of scientists who understood both the magnitude and subtlety of their work. The night of photons had illuminated more than entanglement. It had revealed the nature of inquiry itself. Discovery, they realized, is not always dramatic. Sometimes it is the quiet accumulation of evidence, the patient watching of invisible phenomena, and the gentle recognition of patterns that defy classical expectation, yet make perfect sense in the language of the quantum world. Aspect's experiment would echo through decades of physics. It would inspire future research, influence the development of quantum technologies, and offer a tangible demonstration of concepts that had once seemed purely philosophical. Yet for the team that night, the experience was immediate, intimate, and profoundly human. A shared encounter with the hidden structure of reality, revealed through the subtle choreography of photons dancing across space. As the lab emptied and the city awoke, the night's significance lingered like a soft, persistent note. The world had taken another step toward understanding the delicate, invisible connections of the universe. Entanglement was no longer an abstract idea or a playful paradox. It was measured, observed, and undeniably real. The photons had spoken, and for those who had watched, the language of the quantum world had never been more clear. The results arrived quietly, almost imperceptibly at first. Lines of data streamed from detectors, columns of numbers that at a glance seemed mundane. Yet within them lay a profound truth. Particles, separated by distance, were acting as if they were one. The correlations were too strong, too precise to be explained by local independent properties. Classical physics, which had ruled for centuries, could not account for this. Reality, it seemed, had a subtle, hidden coherence that transcended ordinary expectations. The Bell tests, perfected over the years, confirmed what theorists had long suspected. Entangled particles behaved in ways that violated classical assumptions about locality. Measurement at one location influenced outcomes at another, instantaneously, even when the distance between them was significant. It was not communication in any conventional sense. No signal traveled faster than light. Yet the link was undeniable, woven into the very fabric of the particles' shared existence. In this quiet defiance of expectation lay the essence of non-locality. To grasp it, imagine two entangled particles, one resting on a lab bench in Paris, the other miles away in Marseille. A scientist in Paris measures the first particle's polarization, and immediately the measurement outcome of its distant partner is determined, not through signal, not through conventional cause and effect, but through the entangled system itself. The universe had crafted a subtle thread connecting the two, invisible yet measurable. Each experiment confirmed this again and again, the repetition reinforcing the astonishing truth. The term breaking local reality captures the feeling perfectly. Classical intuition tells us that objects separated by space must be independent. Events occurring here cannot instantaneously affect events there. Yet entanglement challenges this assumption, revealing a world where separation does not guarantee independence. Space, which feels solid and absolute in everyday life, becomes a softer, more fluid concept in the quantum realm. Connections exist where we expected isolation, coherence where we expected randomness. The awe of these results is quiet and reflective. It does not demand excitement or dramatic gestures. It asks only for attention, patience, and contemplation. Scientists watched the data, saw the correlations, and slowly recognized the profound implications. Reality, they realized, is more interconnected than previously imagined. The hidden threads between particles suggest a universe that is both orderly and mysterious, precise in its correlations yet beyond simple causality. Each violation of Bell's inequality was a small miracle, a confirmation of quantum mechanics' predictive power and an invitation to rethink our assumptions. These were not chaotic or random coincidences. They were patterns, consistent and reliable, demonstrating that entangled particles share information in ways that transcend classical limitations. The effect is subtle yet absolute, a calm revelation of nature's unexpected coherence. The implications extend beyond physics. Non-locality hints at a universe that is less fragmented than it appears, where distant events are connected in ways that are invisible yet undeniable. It is a gentle reminder that separation is not the same as isolation, that distance is not the same as disconnection. The hidden threads of reality tie together what our senses perceive as separate, creating a cosmos that is more holistic and interwoven than intuition alone would suggest. Even for seasoned physicists, the sensation is one of serene amazement. The experimental results do not provoke panic or confusion. They evoke quiet wonder, a sense that nature is richer and subtler than previously imagined. To witness non-locality is to encounter the universe at a deeper level, where familiar rules yield to surprising yet consistent behavior. It is as if the cosmos itself is whispering secrets, patiently revealing patterns that transcend our everyday experience. Consider the photon pairs used in these experiments. Each pair is born in a single event, yet travels independently. One is measured in one location, the other in another. Classical reasoning would suggest that once separated, each particle should act on its own, its properties fixed or influenced only by its immediate surroundings. But the experimental evidence contradicts this expectation. The outcomes are correlated in a way that cannot be explained by local factors. Something beyond local reality is at work. The entangled system itself, a unity spanning distance and defying classical partitioning. The elegance of non-locality lies in its quiet certainty. It is not noisy or chaotic. It is precise, replicable, and predictable within the framework of quantum mechanics. Repeated experiments using photons, electrons, and other particles continually confirm these connections. The effect does not weaken with distance, and it adheres to mathematical predictions with remarkable fidelity. This is not a fleeting curiosity. It is a fundamental feature of reality, a window into the deep coherence of the universe. The emotional resonance of these findings is subtle, yet profound. Scientists describe it as awe, not fear. Reverence, not bewilderment. There is a meditative quality to observing the hidden unity of entangled particles, a recognition that the universe contains structures and patterns that are both invisible and undeniable. Non-locality does not disrupt the cosmos. It enriches it, adding layers of coherence that coexist with classical experience. For those engaged in the experiments, the night of data collection is often calm, almost ritualistic. Detectors click softly, lasers hum steadily, and screens display correlations that exceed classical bounds. Each run reinforces the principle that entanglement is real, reliable, and astonishing. The researchers move deliberately, checking alignments, recording outcomes, and absorbing the quiet majesty of the phenomena they observe. This is science as attentive observation, awe balanced with precision, curiosity met with method. Breaking local reality, then, is not a moment of chaos, but a gentle revelation. The universe is not fractured into isolated pieces. It is subtly, beautifully connected. Distance does not sever, separation does not isolate, and measurement does not merely observe. It participates in a deeper, invisible network of correlations. In this realization there is peace as well as wonder. The cosmos, while strange, is comprehensible in its elegance, a calm yet astonishing tapestry of interconnected threads. The experimental results confirm what theory predicted, and in doing so they invite reflection. They remind us that reality is not limited to intuition, that the boundaries of experience can be transcended, and that the universe holds surprises for those willing to measure, observe, and wonder. Non-locality is no longer theoretical. It is tangible, measurable, and undeniably part of the world. The quiet amazement it evokes mirrors the serenity of those who first glimpsed the hidden dance of entangled particles, a profound. The experiments of the late 20th century did not arrive with fanfare. There were no grand ceremonies, no sudden proclamations that the foundations of physics had shifted. Instead, the change unfolded quietly, almost imperceptibly. In the careful notes of laboratory logs, in measured discussions at conferences, and in the growing realization among physicists that reality was far subtler than anyone had imagined. The universe, it seemed, had rewritten its rules without needing to announce them, revealing a quiet revolution that transformed understanding from within. This revolution began with questions, modest in their appearance but profound in their reach. Einstein's skepticism, Bell's clarity, Aspect's experiments, each was a step in a journey guided by curiosity and careful thought. The discoveries did not overthrow the principles of classical physics entirely. Newtonian mechanics still governed the motions of planets, projectiles, and pendulums. Yet at the microscopic level, the world had changed. Connections spanned distances, probabilities dictated outcomes, and the behavior of particles defied intuition in subtle but measurable ways. Physics had expanded its vision, quietly, elegantly, and irrevocably. Reflecting on this shift, one can appreciate its humility. The revolution was not a dramatic collapse of old ideas, but a gentle, patient unveiling of deeper truths. Scientists continued to teach classical mechanics in classrooms, to send spacecraft through the solar system, and to design engines and circuits based on familiar principles. At the same time, the recognition of entanglement, non-locality, and quantum coherence introduced new layers of understanding, demanding attention, reflection, and recalibration of expectations. It was a triumph of thought and observation, yet it wore no garish crown. The quiet nature of this change is fitting, for the phenomena themselves are subtle. Entangled particles whisper across space without sound. Correlations emerge in the flicker of detectors, the pulse of lasers, and the soft hum of electronic instruments. Nature communicates its secrets not through noise or spectacle, but through precise, measurable, yet invisible connections. Scientists, trained to observe, record, and reflect, experience this revelation in a subdued and contemplative way, marveling at the patterns without needing to dramatize them. In this sense, the revolution is ongoing. Each experiment, each technological advance, each theoretical refinement adds depth to understanding. But the core realization remains the same. The microscopic world is interconnected in ways that classical intuition cannot capture. The act of observation is not passive. It is a subtle engagement with reality, one that respects the delicacy of the universe while revealing its coherence. Physics has not merely added knowledge. It has expanded the framework through which knowledge itself is interpreted. The human aspect of this quiet triumph is compelling. Generations of physicists have contributed to this transformation, from thought experiments penned on paper to painstaking measurements conducted under dim laboratory lights. The work required patience, precision, and humility. Errors had to be corrected, interpretations debated, and assumptions challenged. Yet the collective effort led to clarity, a slow accumulation of understanding that now forms the foundation of quantum physics as it is taught, tested, and applied today. It is a revolution that belongs to thinkers as much as to nature itself, a co-creation of inquiry and discovery. Technology, too, began to follow the subtle signals of this revolution. Quantum cryptography, quantum computing, and other emerging fields rely on entanglement and coherence, taking advantage of phenomena that were once purely theoretical. These applications do not shout their novelty. They operate in quiet sophistication, harnessing the principles revealed by decades of careful study. In this way, the quiet revolution extends from laboratories to the practical world, connecting fundamental insight with tangible progress. Yet perhaps the most striking aspect of this change is its invitation to wonder. Even after decades of experiments, equations, and technological developments, the underlying phenomena remain profoundly mysterious. Entangled particles obey rules that are precise, measurable, and replicable, yet they challenge common sense, asking us to rethink assumptions about space, time, and separation. There is a gentle humility in this recognition. The universe is intelligible, yet it contains layers of subtlety that invite ongoing curiosity. The quiet revolution is also a story of continuity. While the microscopic world revealed new principles, the broader framework of physics remained intact. Classical mechanics, thermodynamics, and electromagnetism continue to describe much of the observable world with remarkable accuracy. Quantum mechanics does not erase these truths. It enriches them, adding depth and nuance. It demonstrates that understanding is not linear, that nature can simultaneously obey different rules at different scales, and that intellectual humility is essential in the face of its subtlety. As Chapter 4 closes, one can appreciate the gentle grandeur of this transformation. The work of Bell, Aspect, and countless others did not roar across history. It seeped into understanding like a quiet tide, reshaping the landscape of physics without announcing itself in bold strokes. It altered the way scientists think, the way experiments are designed, and the way reality is interpreted, all while maintaining a calm respect for both observation and imagination. In this calm, reflective triumph, there is also a lesson for those who engage with the universe. True revolution need not be loud. It can be measured, deliberate, and patient, carried forward by curiosity, logic, and careful observation. The quantum revolution demonstrates that profound change can unfold gently, leaving space for wonder, reflection, and the ongoing pursuit of knowledge. The night of photons, the tests of Bell's inequalities, the confirmation of entangled correlations. Each step was a quiet affirmation that reality is more intricate, connected, and astonishing than classical intuition alone could reveal. Physics, forever transformed, moved forward without spectacle, but with clarity, rigor, and humility. The world had taken notice, not in shouting, but in attentive listening, careful measurement, and reflective understanding. This is the essence of the quiet revolution, a subtle, enduring shift in perspective, one that honors both the complexity of nature and the patience of those who seek to understand it. It is a triumph without drama, a celebration without noise, a testament to the power of careful thought, precise observation, and the human capacity to perceive truths that lie beyond immediate intuition. In the quiet, physics changed forever, not with fireworks, but with the gentle affirmation of nature's hidden threads, woven into the very fabric of reality. Imagine a single photon, born from a distant lamp or a star billions of light years away, traveling in silence across space. It moves with a precision and purpose invisible to the eye, yet every flicker, every oscillation, carries a story. This tiny particle, smaller than the width of a hair, is both messenger and message, a quantum letter written in the language of the cosmos. To observe it is to touch a fragment of the universe's ongoing dialogue, a whisper of connection that spans distance, time, and scale. Photons do not speak in words, yet their behavior conveys something profound. They travel in straight lines, obeying the dictates of physics, but when entangled, they carry subtle information about their twin. A measurement on one photon instantaneously reveals the state of another, as if the universe itself had folded space and time into a secret note sent across the void. It is a quiet, magical realism, a letter delivered without envelope, a message encoded in the dance of light. Consider the journey of a photon from a distant star. It begins as a pulse of energy, a spark born of fusion deep within the stellar core. It escapes the star's fiery embrace and drifts into the darkness, passing through vast stretches of empty space. Along its path, it may encounter dust, gas, or magnetic fields, each interaction leaving a subtle imprint, a signature of its passage. The photon is a traveler, a chronicler of everything it touches. And when it reaches a detector or a human eye, it delivers a story accumulated over cosmic scales. Entanglement transforms this journey into a shared narrative. Two photons, born together and separated by distance, maintain a link that defies classical intuition. Their properties are correlated, as if they share a memory of their creation. A measurement on one photon instantly informs the state of the other, regardless of the kilometers or even light years between them. It is as if the universe has whispered a secret across space. That separation does not sever connection. That distance is a pliable concept when it comes to the threads of quantum coherence. There is poetry in this subtle communication. A photon is not merely a particle of light. It is a messenger carrying encoded information about its origin, its partner, and the fundamental laws of the cosmos. Its oscillations, polarizations, and correlations are letters in a language older than human understanding. To watch a photon behave in this way is to read a note from the universe itself. Written in symbols we can interpret only through curiosity, attention, and imagination. Imagine standing under the night sky, looking at a single point of light. That star may have emitted countless photons, each traveling for millennia before arriving at your retina. Each photon carries with it a story of fusion, travel, and entanglement. Some photons may have counterparts, twins whose fates are bound invisibly across distance. The moment of observation, whether by telescope, detector, or eye, is the moment of revelation. The universe whispers back and we hear faintly the interconnectedness of all things. Scientists often describe these interactions in technical terms: polarization, correlation, measurement, yet the effect is profoundly poetic. A photon's behavior reflects patterns and symmetries that speak to a deeper order. It obeys rules that are precise, yet the manifestation of these rules feels like a gentle magic. Each entangled photon is a note in a symphony, every measurement a chord that harmonizes across distance. The language of quantum mechanics, though exacting in its mathematics, reads like poetry when imagined in terms of connection, travel, and the quiet dialogue of particles. The magical realism emerges in the simultaneity of opposites. Photons are both particles and waves, independent yet connected, local yet non-local. They defy expectation, revealing a universe that operates on principles both orderly and mysterious. Observing these behaviors evokes wonder, not confusion, delight, not fear. It is a gentle awakening, an understanding that the cosmos speaks in whispers and symbols, inviting those who listen with patience and attention to perceive its hidden harmonies. Even the act of measuring a photon becomes poetic. When a detector registers its presence, it collapses the possible states into a defined outcome. The photon's message, previously encoded in probabilities and potentialities, becomes tangible. Yet the story does not end. Its entangled partner, perhaps across the room or across the world, reflects that same truth instantaneously. The measurement is both an ending and a revelation, a quiet punctuation in the ongoing narrative of the universe. The metaphor extends further. Photons remind us that the smallest things can carry the greatest significance. A particle so tiny it slips unnoticed through the vastness of space can reveal profound truths about connection, causality, and the structure of reality. In this sense, the universe speaks not only through grand galaxies or cosmic phenomena, but also in the delicate choreography of particles that move unseen, leaving trails of insight for those who seek them. To embrace the message of the photon is to cultivate curiosity, wonder, and attentiveness. It is to recognize that reality contains layers, each more subtle than the last, and that understanding requires both observation and imagination. The universe whispers in quiet ways, through particles that traverse unimaginable distances, through correlations that defy classical expectation, and through phenomena that reveal an interconnectedness far beyond everyday experience. In this quiet, magical realism, we find a sense of belonging. Humans are part of a cosmos where connections persist invisibly, where energy travels with purpose and coherence, and where observation itself is an act of engagement. The photon is a messenger, but also a mirror. It reflects the human capacity to perceive, interpret, and marvel. Its message is both literal and symbolic, scientific and poetic, technical and mystical. It asks us to listen, to wonder, and to recognize the subtle threads that bind reality together. And so each photon becomes more than a particle. It is a letter from the cosmos, a note in the eternal symphony of entanglement, a whisper of connection that transcends distance, time, and expectation. Observing it, we are reminded of the universe's quiet majesty, precise, subtle, interconnected, and endlessly wondrous. The message is simple and profound. Even in the smallest flicker of light, the universe speaks, and when we attend with care, it whispers back. Consider two particles, born in the same moment, their existence intertwined in ways invisible to the eye. One remains in a laboratory, monitored by meticulous instruments. The other travels far away, perhaps kilometers, perhaps across continents. No signal connects them, no conventional path carries information between their locations. And yet when one is observed, its partner reveals complementary behavior instantaneously. Distance, it seems, is irrelevant. The universe maintains its coherence, indifferent to space and, intriguingly, time itself. Entanglement challenges our intuitive understanding of separation. In everyday life, objects are distinct. What happens here rarely affects something far away without interaction. But quantum particles behave differently. Their shared state does not depend on proximity. A measurement performed in one location reflects in the other, as though the universe's architecture is a delicate lattice of invisible threads, stretching across vast distances. There is no struggle against time or space. The connection exists naturally, persistently, effortlessly. This indifference to distance evokes a serene kind of wonder. It is not startling or alarming. It is gentle, almost meditative. Scientists performing long-distance experiments often describe it as observing a hidden harmony, a quiet coherence that underlies apparent separation. When photon pairs are tested in distant labs, the correlations remain intact. The farther apart they are, the more it feels as though the universe is subtly affirming its unity, as if to whisper that space is a softer boundary than we perceive. Imagine a photon traveling through optical fibers or across open air. Its partner measured elsewhere at the same moment. The results consistently defy classical expectations. No matter the separation, the entangled pair maintains its shared state. There is an elegance in this defiance. The universe does not bend to human intuition. It simply is. Time and space, fundamental to our perception, are less restrictive at the quantum level than we might imagine. Entanglement exists in a dimension of coherence that stretches and flows beyond conventional limits. Experiments reinforce this awe. In some cases, researchers have separated entangled particles by hundreds of kilometers, observing that correlations remain perfectly consistent, even when measurements are performed randomly and rapidly, ensuring no possibility of classical communication. The outcomes match the predictions of quantum theory. The particles act as one, synchronized across empty space, indifferent to barriers, indifferent to distance, as though reality itself is threaded with an invisible order. There is also a subtle poetic resonance in this behavior. To see entanglement across space is to witness a gentle conversation between distant points, a quiet dialogue that unfolds without sound or signal. The particles do not shout, do not race toward one another. They exist in parallel, yet their fates remain intertwined. The effect inspires reflection. The universe is not merely a collection of isolated objects, but a web of relationships, a latticework of connection extending beyond what the senses immediately reveal. Time, too, seems to bend under this principle. While entangled particles are measured at the same moment in one frame of reference, their connection persists regardless of the history or future of their individual paths. The correlations depend on the entangled state, not the journey, not the sequence of events. One can imagine a photon created years ago, traversing space paired with another, and still exhibiting the same instantaneous correlations when measured today. The temporal indifference adds another layer to the quiet awe of entanglement. The universe threads connections that defy not only distance, but also the linearity of our experience. This perspective encourages a gentle humility. We perceive the world as divided by space and time, yet nature reminds us that these divisions are not absolute. Entanglement reveals a subtle architecture underlying reality, one that is precise, reliable, and astonishingly consistent. It invites calm amazement, a recognition that the cosmos holds patterns beyond what we initially perceive, and that observation is a window into an interconnected, expansive order. The feeling is almost meditative, watching correlations hold across distance, observing that a particle here and its twin elsewhere respond as one. We sense a quiet order behind the apparent randomness of the universe. The discovery does not demand excitement or dramatic gestures. It asks for attention, reflection, and wonder. The vastness of space does not dilute coherence. It frames it, highlighting the resilience and subtlety of quantum connections. Entanglement's indifference to distance also reshapes imagination. Communication becomes a metaphorical bridge. Inspiration stretches across continents, and understanding transcends the immediacy of location. Though the practical applications are complex, quantum cryptography, teleportation experiments, and secure information transfer. The poetic resonance is simple. The universe is more connected than we often realize. Distant events can resonate together in quiet synchrony, showing that separation does not always mean isolation. Even everyday perception gains new dimension. We inhabit a world that seems fragmented, yet quantum mechanics suggests an underlying coherence that quietly supports everything we see. Entangled particles act as a reminder that connectivity exists on levels invisible and essential. Their behavior invites observation, contemplation, and awe. The effect is calming. It is the subtle reassurance that, at its core, reality is coherent, ordered, and astonishingly intricate. In this airy landscape of thought, the universe feels alive with connection. Photons, electrons, and other particles trace invisible paths that intersect, align, and reflect each other across unimaginable distances. It is a world where distance is a guideline, not a limitation, where space does not prevent conversation, and where the cosmos, quietly and patiently, maintains harmony. The experience fosters a gentle respect for the hidden architecture of nature, a calm marvel at how finely the universe is tuned. Across time and space, entanglement demonstrates that the universe operates not only in what is immediately visible, but also in subtle, enduring connections. It is a phenomenon that invites quiet reflection, a serene acknowledgement that distance is not the end of interaction, and that particles, like threads of thought, may remain linked regardless of separation. To witness it is to feel a deep, airy awe, to recognize a hidden unity, and to understand that the cosmos, in its patient precision, often whispers truths far beyond ordinary. Human curiosity has always reached upward, toward the sky, toward the stars, And now, in the age of quantum exploration, even the cosmos itself has become a laboratory. Entanglement, once confined to carefully controlled tables in laboratories, is now being tested on scales that would have seemed impossible just decades ago. Satellites carry delicate instruments into orbit. Beams of light traverse kilometers of vacuum, and the universe itself becomes a stage for particles to perform their silent, synchronized dance. Consider the experiments conducted using satellites equipped with photon sources and detectors. These machines orbit the Earth high above the noise of cities and the turbulence of the atmosphere. They emit pairs of entangled photons, sending one toward the ground and keeping the other in space, or beaming each to different locations separated by hundreds of kilometers. Despite the immense distances, the photons' correlations remain intact, matching the predictions of quantum mechanics with remarkable fidelity. The results confirm that entanglement is not a laboratory curiosity. It is a property of nature itself, resilient even in the harsh, shifting conditions of space. The technological achievement is impressive. Engineers must account for the motion of the satellite, the effects of gravity, atmospheric refraction, and the delicate timing required to detect photons traveling at light speed. Yet for all this complexity, the core message is elegantly simple. Entangled particles act as one, regardless of the vastness that separates them. It is as if the universe itself allows these connections to endure, unaffected by obstacles that seem insurmountable in everyday experience. The calm precision of these experiments mirrors the patience of the cosmos, which has maintained coherence across space and time for eons. Some experiments reach even farther, testing entanglement over distances comparable to the Earth's diameter. Photons emitted from a satellite are received at ground stations thousands of kilometers apart. Rapid random measurement settings ensure that no classical signal could explain the correlations. The results are consistently astonishing. Despite the intervening distance, the particles' behaviors remain entwined, demonstrating non-locality on a planetary scale. The sense of awe is quiet, contemplative, a reminder that the quantum world is not bound by the limits we perceive in our macroscopic lives. Cosmic experiments push the boundaries even further. Scientists have begun exploring entanglement using photons from distant stars and quasars, taking advantage of light that has traveled billions of years. These cosmic photons are measured and compared, sometimes using their polarization states to test the robustness of quantum correlations. Here, entanglement is not a human-engineered phenomenon. It is woven into the fabric of the universe itself. The distance is not merely terrestrial but cosmological, and yet the correlations remain consistent, confirming that the principles of quantum mechanics apply universally, not just in laboratories. The futuristic nature of these experiments is matched by their quiet, soothing elegance. Unlike dramatic explosions or high-energy collisions, these tests rely on delicate, precise measurements. Detectors click softly, satellites drift in silent orbit, and light beams travel through space without fanfare. The effect is meditative. The universe offers a subtle demonstration of its coherence, and humanity watches, measuring, recording, and marveling. It is a moment where technology and nature meet in quiet harmony, revealing fundamental truths without spectacle. This interplay between human ingenuity and cosmic scale evokes reflection. By sending photons across space, by aligning instruments across continents, scientists participate in a dialogue with the universe itself. Each measurement is a note in an ongoing symphony, each correlation a testament to the underlying order of reality. The results are not instantaneous answers, but gentle confirmations, an ongoing conversation that spans distances previously unimaginable. The practical implications are already emerging. Quantum communication networks and secure channels may one day rely on satellites and entangled photons, ensuring that information is transmitted with security guaranteed by the laws of nature. But even beyond application, the philosophical resonance is profound. The experiments suggest a universe that is subtle, resilient, and interconnected. A cosmos where distance does not necessarily mean separation, where particles carry messages across unimaginable scales, and where reality itself is a coherent tapestry stretching across the stars. Cosmic entanglement experiments also inspire a sense of continuity. The photons traveling from distant stars have existed for billions of years before being captured by human instruments. Their entangled states may reflect correlations established long before Earth itself existed. Observing these particles is to witness a connection that transcends human timescales, a quiet affirmation that the universe operates with a persistent underlying coherence. It is a humbling reminder that our place in the cosmos is both fleeting and deeply connected to forces far older and broader than ourselves. The serenity of these experiments is part of their wonder. Satellites glide silently, photons traverse vacuums without friction, and detectors quietly capture fleeting events. There is no clamor, no dramatic crescendo, only precise alignment, repeated trials, and the serene unfolding of natural law. In this quiet, humanity glimpses a truth that is both astonishing and comforting. Even across the immense distances of space, the universe maintains order, connection, and subtle beauty. Ultimately, these experiments extend our understanding not just of entanglement, but of reality itself. They show that the quantum world is persistent, universal, and resilient. Distance, once thought to impose isolation, is revealed to be a stage rather than a barrier. Entangled particles, whether in a lab or among the stars, act as threads linking the cosmos in invisible yet undeniable ways. The sense of awe is calm, reflective, and inspiring, a reminder that science, patience, and curiosity can reveal the poetry of the universe. Watching the results arrive from satellites and cosmic sources, scientists experience a quiet triumph. The data confirms what theory predicted, yet the scale amplifies its significance. Entanglement is not local, fragile, or fleeting. It is universal, enduring, and profoundly beautiful. Humanity, in its smallness, becomes a witness to these hidden harmonies, participants in a vast, subtle dialogue that stretches across planets, stars, and the very fabric of reality. In the end, experiments across the stars teach us that the universe whispers in photons. And when we listen with care, the message is clear. Connections endure, distances collapse in subtle ways, and reality is more wondrous than imagination alone could conceive. Futuristic in scope, yet soothing in experience, these cosmic tests of entanglement reveal a quiet majesty, a universe that is at once immense, precise, and infinitely interconnected. There is a quiet art to understanding the universe, a subtle skill that unfolds not through loud instruments or dramatic displays, but through patience, attention, and reflection. Humanity has learned over centuries to observe the heavens with care, to measure the motion of stars, the pulses of photons, the faint flickers of distant galaxies. In the quiet of observation, the cosmos speaks, not with shouts, but with whispers, subtle harmonies that reward those who listen closely. Scientists have become attuned to these whispers. Detectors register fleeting flashes of light, instruments measure minute changes in polarization, and telescopes capture photons that have traveled billions of years. Each signal is delicate, often barely distinguishable from background noise, yet each carries the imprint of the universe's structure and behavior. To the trained observer, these faint messages are rich with information, revealing patterns and connections that are invisible to casual perception. Listening to the cosmos is both scientific and poetic. It requires a mind capable of precision and a heart receptive to wonder. When a photon from a distant star exhibits entanglement with a twin particle, it communicates a subtle truth. The universe is interconnected in ways that transcend ordinary experience. Humans, by learning to measure, to interpret, and to contemplate, become participants in a dialogue with the cosmos, perceiving patterns that are older than the Earth, spanning space, and enduring across time. The practice of listening cultivates a meditative awareness. There is no rush, no urgency. Measurements are taken carefully, repeated to ensure reliability, and analyzed with thoughtful patience. Each step invites reflection. The observer is reminded of their smallness in relation to the vastness of space, yet also of their unique capacity to perceive and understand. In this gentle balance, awe and humility coexist, creating a contemplative state in which the universe feels simultaneously immense and intimately accessible. Consider the patterns revealed by entangled particles. Two photons separated by kilometers measured at different locations reflect one another's states instantaneously. The connection is not visible, not audible, yet it is real. It can be inferred, quantified, and appreciated. To witness this is to sense a quiet harmony, a web of correlation that binds seemingly distant points into a coherent whole. The experience is meditative. Understanding emerges not in forceful insight, but in careful, attentive perception. Listening to the cosmos also nurtures patience. Signals arrive slowly, data accumulates incrementally, and patterns become clear only after meticulous analysis. There is no immediate gratification. The reward lies in sustained attention, in the gradual revelation of coherence amid apparent randomness. Scientists and observers alike learn to wait, to measure and to reflect, and in doing so, they begin to sense the rhythm of the universe itself, a quiet cadence that underlies both motion and stillness, distance and connection. The act of listening extends beyond instruments. It is also a contemplative practice, a way of attuning the mind to subtlety, of perceiving patterns in nature and in life that might otherwise go unnoticed. When one observes a flock of birds moving in perfect formation, the ebb and flow of tides, or the cycles of seasons, there is a resonance with the principles glimpsed at the quantum level. The universe whispers, and those who listen notice echoes of coherence across scales, from photons to planets, from particles to people. This meditative attunement has ethical and emotional dimensions as well. Recognizing connection fosters empathy. The universe is not fragmented, and perhaps we, too, are part of a web of relationships that transcends the immediate. Observing entanglement and coherence invites a sense of belonging, a reminder that separateness is not the full story. In understanding the subtle harmonies of reality, humans may cultivate care, patience, and attentiveness in their lives, reflecting the quiet patterns they observe in nature. Listening to the cosmos encourages wonder without demand. It does not insist that one understand everything immediately, nor that insight be dramatic or complete. Instead, it offers a gentle, ongoing invitation. Pay attention, notice the connections, appreciate the rhythms, and recognize the subtle coherence that underlies both chaos and order. In this practice, curiosity becomes a meditation, observation a form of mindfulness, and science a bridge to both understanding and awe. There is also a temporal dimension to this listening. Photons arriving from distant stars carry stories that began millions or billions of years ago. Measuring their entangled correlations connects the present observer with the deep past of the universe. The experience is humbling. One is aware of the continuity of time, the persistence of physical law, and the subtle intelligence embedded in the behavior of matter and energy. The cosmos speaks slowly, and learning to hear it requires matching that tempo with quiet attentiveness. In quiet observatories, under night skies or through instruments orbiting Earth, humans practice this attentive listening. Every measurement, every observation is part of an ongoing engagement with the universe. The results affirm that reality is more interconnected than our senses suggest, more coherent than intuition alone would indicate, and more wondrous than imagination can fully encompass. To witness this is to participate in the universe's subtle dance, to perceive its harmony, and to be transformed by the awareness that we are observers and participants in a cosmic dialogue. Ultimately, listening to the cosmos is both an act of science and an act of meditation. It is the practice of attending to patterns, correlations, and connections that exist beyond immediate perception. It is the cultivation of awe, humility, and attentiveness. And it is the recognition that the universe, in its quiet elegance, continues to speak, and that we, by listening carefully, may begin to understand, reflect, and marvel. The cosmos whispers in photons, in entangled pairs, in distant starlight, and in subtle correlations that endure across time and space. Those who learn to listen hear not noise or chaos, but a gentle, consistent harmony. It is a lesson in patience, wonder, and connection. A meditative closure to the story of entanglement and the quiet revelations it brings. In listening, humans find not only knowledge,